Hello everyone, welcome back to Calculus 2. So in this video, we're going to talk about 1.6 integrals involving exponential and logarithmic function. So as you see in the title, the question is pretty simple. What if you are dealing with exponential or logarithmic function? How would you be able to take the integral, right? So as you know, you guys been learning so many different kinds of functions since, long time ago: linear function, quadratic polynomial, rational trigonometry, exponential log function, composition function. Especially in the last video, 1.5, we talked about how to take the integral when you are dealing with the composition function. So in this video, we are going to talk about how to take the integral when you're dealing with the exponential and logarithmic function, okay? So we have to take the integral, and then we never know what kind of function you're going to deal with. So especially when you're dealing with the exponential and log function, the following techniques will be used. So in this video, I'm not really, focusing on the proving stuff. So this table, this strategy, it's a given if you're going to Canvas. So let me just go to Canvas shell for quickly. If you go to our Canvas shell, so let me just go back to our Canvas shell main page. So as you know, you can take a look at all the information in our Canvas. So hold on a second, it's a little bit slower. So let me just, okay, now it's getting better. So this is our Calculus 2. So if you click module, right, as I mentioned, there are the table of integrals and table of derivatives. This is kind of your like a Bible. So if you click so you've been using table of derivative when you're taking Calculus 1. So we're gonna click table of integral. And here are a bunch of the integral techniques that helps you to find out the final answer. So these are all the basic integral, and there are more, integrals techniques. We have a lot. So what I'm saying is, what if you are taking the integral, especially with like exponential function or log function, what would be the outcome? So it's a given. You don't need to memorize it. This is kind of your like your referral paper. So always I encourage you guys to utilize this table. So let me go back to our lecture notes. So this is the thing. If you are taking the integral with the exponential function, especially e to the x, the outcome is going to be same e to the x. Do you remember when you're taking the derivative of e to the x function, it was always equal e to the x. So therefore, if you're taking the integral of the e to the x, it's going to be the same e to the x. So this is so true. And then second thing, what if you have constant e to the kx? Make sure you're going to divide it by that constant and keep the same e to the kx. For example, if I have integral e to the 2x, it is going to be, you're going to keep the e to the 2x and divide it by that constant. So that's the second, techniques. And then I think this one is the same thing. So I'm going to get rid of it for a second. So we don't need to that. So the next one is, what if you are talking about the constant? So for example, if you have 2 to the x, so this is a part of the exponential function, but your base is going to be the number. So keep the same 2 to the x and divide it by ln that base 2. So make sure you don't need to memorize them. You're going to use them by looking at the referral sheet in our Canvas module. Okay, so it's always a given. And last one, if you're taking, this is the same meaning, integral 1 over x dx. This is a very popular ln x, absolute value. So we're going to utilize those 4 log and exponential function in terms of the integral. So make sure we're going to think about it. Those 4 property when you're taking integral in terms of the exponential function. So you don't need to memorize that. I told you it's going to be given. So let me show you the example, how we're going to do that. Sometimes we have to use the, use substitution rules. So I will show you the example so that you can understand how to take the integral when you're dealing with the exponential function, okay? So just make sure those are 4 property exactly right there. So let's take a look at the example 1. Okay, guys, what's going on? So you feel like there's something going on. This is not simply e to the x. I have, 3 minus x to the second has been subbed into the u. So you know here, e to the x, and then 3 minus x to the second has been subbed there. So obviously you feel like this is a kind of like composition function. And then you're going to find out something later, what the x times dx. Are you familiar with that? So just we are dealing with the composition function plus exponential function, 2 different type of function together. So we're going to start work. Let u equal to 3 minus x to the second. So we know take the derivative du over dx, negative 2x. So cross multiplication, negative 2x times dx, that is a du. And then I want to find out x times dx. So what happened? I'm going to divide it by here. I'm going to divide it by negative 2 on both of sides so that I can find out negative 1 over 2 du equal to cancel, x times the dx we're looking for. So x times the dx, we just found out that is negative 1 over 2 du. Okay, so far so good. And then keep going. That is equal. We have e to the u, am I correct? Because the 3 minus x to the second is a u. And x times the dx, we just found out that is negative 1 over 2 du. Beautiful. Now I'm going to bring the constant to the front. So negative 1 over 2 e to the u du. And now here you're going to utilize one of the techniques. So watch me. So you are taking the integral e to the u. You're taking the integral of exponential function. So what happened? E to the u, it's going to be same as e to the u after you're taking the integral. So what happened is negative 1 over 2. You're taking that integral, it's the same e to the u. That's it. And then plus a c. So the answer is negative 1 over 2 e to the u plus c, or you can go back to the x variable, e to the, what was x? 3 minus x to the second plus c. How you feel? So we are definitely utilizing the u substitution because one of the function has been subbed into another one. But when you see the structure of the function, it is an exponential function. So how to take the integral when you're dealing with the exponential, especially e to the x, e to the u, it's going to be the same thing. So you can find out the answer right there. Okay. I think it's getting better. I hope so. So let's take a look at the following example. We're going to keep practicing. So make sure we are dealing with the exponential or log function. You don't need to be scared. Look at that given information. Okay. All right. So let's look at the next question. So 2x to the third, e to the, so this is exponential function. And what happened? 0.1 x to the 4 has been subbed. Because e to the x and 0.1 x to the 4, this function has been subbed into the exponential function. Oh, we're going to use the u substitution. U equal 0.1 x to the 4. And then we're going to take the derivative, 0.1 times the 4, because you're going to multiply and you're going to reduce now x to the third. That means du equals 0.4 x to the third times the dx. Okay, sounds good. But I want to find out what the 2x to the third times the dx in terms of the u variable, isn't it? So let me change it 0.4. This is a 4/10, which means a 2/5. So let me change that decimal to the fraction. So du, that is the same as 2/5 x to the third dx. Okay. It's getting close. It should be 2x to the third dx. How do I convert 2/5 to the 2? You're going to simply multiply 5 here and 5 on both sides. You will get this answer. What happened? 5 du, 5 cancel. Gotcha. 2x to the third dx. So you have 2x third dx is 5 du. Beautiful. That's all I need. That's all we need. Good. So now you can continue. So that means now integral, we have e to the u, correct? Because 0.1 x to the 4 is u. And then 2x to the third dx, we just found out that is a 5 du. Beautiful. I'm going to bring 5 to the front, e to the u, du. Everything is now in terms of u. Ooh, what happened? Now, this part that is equal to e to the u, according to number 1. And then we keep 5 plus c. And you can go back to the x variable, e to the 0.1 x to the 4 plus c. That's your final answer. How you feel? You feel like you got this. I'm pretty sure you got it. We are keep building the same knowledge, from previous chapter, and I'm just changing the type of function. What if you're dealing with the composition function? What if you're dealing with the exponential or log function? There are given techniques, right? But think about it. U substitution, I see you, something is a sub into another. Okay, what is the integral of the exponential function? Look at those for information. Okay, so we are doing awesome. I'm gonna keep, practicing with you guys with a little bit of challenging question. So here we go. All right. Ooh. Okay. What's going on here? Professor Ben. Oh, I don't see the exponential. I don't see the sub. So how do I take the integral? 1/3x plus 4. So when I look at this, let's modify a little bit. This means 1/3x plus 4 dx. Okay, I don't see the exponential, function or nothing. So if you keep modifying one more step up, you know that 1/x is the same as x to the -1. Do you remember from pre-calculus? Reciprocal negative exponent, you can change it to the positive by reciprocaling, the fraction. So it means what? 3x plus 4 to the -1. That's the 1/3x plus 4. So many people forgot this part. I'm going to really, really highlight it. 1/3x plus 4, that is the same as 3x plus 4 to the -1. So by looking at this format, now you see that we have -1 power function and 3x plus 4 has been subbed there. You can use a u substitution. Beautiful. So right there, let u now become 3x plus 4. And then you're going to find out what the dx, because I don't see anything except dx. So here we have 3x plus 4 has been subbed, and then take the u substitution. So du over dx, that is equal to 3. So du equal to 3 times the dx. So far, so good. So then what happened? To find out what the dx only, I'm going to divide it by 3 both of sides. So then it is going to be du over 3. In other words, that is 1/3 du equal to cancel dx. I got you. So dx is 1 over 3 du. Beautiful. So now you know what to do. So that is now integral u to the negative 1 dx is 1 over 3 du. I'm going to bring 1 over 3 to the front. And u to the negative 1, make sure, u to the negative 1, it means the same as what? It means the same as what? 1 over u du. Am I correct? So now all you need to do, you are going to take the integral of what the 1 over u du. So look at this, the last one. Do you remember? So don't take the integral with the basic, thing. It's not, you're not going to plus 1. So if you do here, so many people feel like, oh, Professor Ben, negative 1 plus 1. Wait, it's going to be undefined. So don't do that way. Look at this. What did I say here? If you have integral 1 over x dx, it is going to be ln absolute value x. So we are going to use that property. So it's going to be ln absolute value u. And then I do have 1 over 3 plus c. Are you following? So since if you want to just using adding plus 1 divided by that exponent, you see that it's undefined. Because you're going to divide it by 0, it's going to be undefined. So it's not going to work. You're going to use that property. That's why. So if you have a 1 over u, whatever the 1 over simple variable, it's going to be ln. So therefore, I can go back to the x variable. 3x plus 4 plus c. That's your answer. Are you okay with that? Yes. So I'm going to minimize it a little bit so you can get this idea. Okay. We got it. You got this. So take a moment, think about it. You're keep building your own critical thinking and mathematical skills. Okay. So let's take a look at the following question. I just want to, just a little bit of typo. So let me change the function a little bit. It is actually 3 plus 6x. So now we're going to start it. All right. So Professor Ben, here, I don't see any exponential format. Okay. So we're going to modify this. What happened? That means 3 plus 6x, this is the numerator, times 1 over denominator, x plus x second, dx. I'm trying to modify to find out if there's any sub function. Okay, it's a 3 plus 6x, and then we know this guy is same as x plus x to the second to the negative 1. So therefore, by doing this work, I can find out what is a sub. X plus x to the second has been sub, and you're going to find out 3 plus 6x times dx in terms of the u variable. Are you following? Great. So let's say u equal x plus x to the second. Take the derivative, right? So du over dx, it's a 1 plus 2x. So that means du equal to 1 plus 2x times dx. Beautiful. Now what are you going to do? I want to find out 3 plus 6x. So you already feel it. What if I multiply? What do you think? If you multiply 3, 3, what happened? It is going to be 3 du will be, you're going to do the distributive property, 3 plus 6x and dx. So dun. We got 3 plus 6x dx will be 3 du. Awesome, awesome, awesome. So now you got all the information. So we have that is equal in terms of u. We have u to the negative 1 times 3 plus 6x dx, that is a 3 du. That means 3 u to the negative 1 is a 1 over u du. Am I correct? And what do you remember? This part, if you just take the integral plus 1 divided by it, it's undefined. It's what? Right there. It is ln. So this is ln u. And I have a 3 plus a c. And I can go back to the x variable, ln, through x plus x second plus c. That's your answer. This is ln. Are you okay with that? So you got this. You definitely got this. Think about it. It's a fun topic. You're keep building your step-by-step work. Awesome, isn't it? So likewise, I'm helping you keep practicing more practice question. Okay, are you ready? So let's take a look at the following question. Example 3. So definitely, tangent x, oh, I don't see any exponential. So we have to think more critically, okay? A little bit, deeper level. Tangent x, you actually know what that is. If you remember, tangent x in geometry or trigonometry course, it's the same as sine x over cosine x. That's one of the identity. Tangent x is the same as a sine x times a cosine x. So I'm going to highlight them. Tangent x is the same as a sine x over cosine x as a one of the property. And then, I can keep modifying it. Sine x over cosine x means sine x times 1 over cosine x dx. You see what I'm doing now. And then that fraction, I can keep modifying it. Sine x cosine x to the -1 dx. So this part, 1 over cosine x the same as cosine x to the -1. Isn't it? Why am I doing this? Because I want to find out sub. So, whatever to the negative, cosine x has been sub there. Oh, we can use a u substitution. And then you definitely find out what the sine x times dx in terms of u. So you have to think about this information. Oh, you can keep modifying so that you can use one of the techniques that you know. All right, we got you. So now let u is a cosine x, du over dx. Somebody can search. You can go back to module. What is a derivative of cosine x? Negative sine x. Don't forget that. You got this from calculus 1. So that means du equal to negative sine x dx. Okay, so what happened? All I need is a positive sine x. So negative du is a positive sine x dx. That's something I wanted. So sine x dx, we have negative du. Beautiful. So let's wrap up. So we have here integral u to the -1 sine x dx, that's minus negative du. I'm going to bring negative to the front and u to the -1. I'm going to change another color. That is what? 1 over u. So it is going to be integral 1 over u du. Are you following? So here, I can take the integral with the number 4, right? So it says, right, 1 over x. It's going to be ln u. So we have negative ln u, and I have a negative, and I have a plus c, correct? You can go back. Negative ln u was cosine x. And then here, this negative is a little bit bugging me. So please remember, if you remember in long time ago, in pre-calculus, there's one of the property. Do you remember ln x to the -a? Whatever the negative or positive exponent, you can bring it to the front. So -a ln x, or ln x to the 2, you can bring this to the front to ln x. So this is one of the property in log function. So therefore, this negative actually came from here. So what I'm saying is ln cosine x, and then we have to the -1, right? So that means plus the c at the end. And then this means ln, you can bring -1. Actually, I can bring this -1 here inside, right there. So negative cosine x to the, this is 1/cosine x plus c. And then if you remember, 1/cosine x is the same as secant x. So therefore, the final answer is this. You can check with that. So what I'm saying is, I'm going to make a little bit of note for you. To understand this question, check the identities of log function. For example, log 1 is always 0. Second, log x plus log y, you can multiply, correct? If you remember log x over y, log x minus log y, as long as you have the same base, log x over y. The last one, log base x to the n, you can bring this n to the front. So that's actually what I did right there. I'm going to highlight that right there. This negative, you can move according to number 4. So that's how we got cosine to the -1. So that is 1/cosine x. And then many people forgot as well. What is that? You know, sine x is 1/cosecant x. Cosine x is 1/secant x. So that means cosecant x is another means 1/sine x. Secant x is another means 1/cosine x. So according to the trigonometric function, we can finalize 1/cosine x is a secant x as well. So that's your answer. So there's ln. So remember, integral tangent x, we just found out, ln absolute value secant x. So let's check if it is true. Let's go to table. So if you remember, we just take the integral tangent, we got the same answer. You see that? Right there? We just prove it. We just proved number 11. Tangent x, if you take the integral of tangent function, we just proved that is ln absolute value secant, which is we just proved it by using the techniques of the use substitutions and the exponential outcome. Does it make sense to you? Yes, it is a very popular question. So I'm gonna do number 2. So we have to do this one. I think I need a definitely space. I'm gonna make a little bit smaller. So identity. So let's do this one right there. Are you okay with that? So let me write down that question in the bottom. So the question was, okay, guys, in this time, e to the cosine x times sine x dx. Look at that. We have the specific interval. So you don't need to scare of it. We just gonna, this is a definite integral. We have a specifically. So whatever you finish the work, you're gonna subtract large to the small area. So we're gonna do the work. Are you ready? So first of all, in this question, I see you cosine x has been sub into the e to the x function. So this is easy to check. So therefore, you're gonna start let u equal to cosine x. So du over dx, that is gonna be negative sine x, isn't it? And then what happened? Du cross multiplication, negative sine x times dx. I need what the positive sine x times dx. I'm going to divide it by -1. both of sides. So then negative du equal to positive sine x dx. So we have sine x dx, it is negative du. And don't forget that this is a definite integral. What do you remember? We have to change the interval. So 0, pi over 2, this is in terms of the x variable. We need to change it to in terms of the u variable. So the u, when x equal to 0, cosine 0, it's a 1. When x equal to pi over 2, so cosine pi over 2, it's going to be 0. So just go to the cosine function. Cosine 0 is 1. Cosine pi over 2 is a 0. So we have a 0, 1 in terms of the u variable. So that's your new interval, correct? So we're going to set it up, all the questions. So this one now, integral 0 to 1, e to the u, and then sine x dx, that's negative du. Gotcha, we're going to solve that question. Okay, so we got it. Now what happened? We're going to work on this u integral. So therefore, I'm going to bring negative to the front. So we have a 0 to 1. I have a little bit of here. I have a little bit of question mark. You have to think about it. 1 second. 0 become 1 and pi over 2 becomes 0. So let me just rewrite it. 0 become 1, pi over 2 become 0. So it says 0 to pi over 2, if you are making the order correctly, it's a 1 to 0, isn't it? Am I right? And then this does not make sense, right? Because the 1 to 0, so I'm going to write a little bit of note before we're going to conduct. So note, if you a to b, f of x dx, you can change a to b, b to a, if you have the negative into the front. So this is the, you learn in last, chapter, I think the beginning chapter. So note, so because of this fact, I'm going to modify this, right? It's going to be equal negative, and then I have integral now 0 to 1. You're going to have a negative to the front because we are changing 1 to 0 to 0 to 1. Does it make sense? And the rest of things same, e to the u, negative du. So make sure that's something we need to consider. Because we have 0 go to 1, pi over 2 go to 0, and then that means exactly from 1 to 0, but that's not make sense. So according to the note, we need to adding negative to the front so we can have a better order from 0 to 1. Got you. So that's something please consider. And now we're going to do the work. Bring this negative to the front. So double negative change to positive, 0 to 1, e to the u du. We got it. And then e to the u, right? This one, what happens? Same as e to the u from 0 to 1. So we have capital 1 minus capital 0. So you get e to the 1 minus e to the 0. E to the 1 is e. E to the 0 is 1. So that's your answer, e minus 1. Ah, we got this. So I'm going to hold up here for a second. Does it make sense to you? Yeah, it makes sense to you. I hope so. Yes. Very, very, very important question. Yeah. Okay. So we now understood when and how you're going to use a use substitution method. Even though you're dealing with the exponential or any other function, you can have a subfunction. So therefore, that's one of the example. All right. So I think this is getting better and better. I'm going to keep practicing with you 2 more examples. You ready? Here we go. So the next step is I'm going to show you all the definite integral. You know what that means, definite. We have a specific integral. So it's not a big deal. So we already know how to take the integral, with the exponential or log function. So keep utilizing. I'm going to get rid of this. This is the same. And then we know when and how you're going to use a chain rule. So just take the integral. If you have an integral with the specific integral, convert it to the x to the u variable integral. So same thing, we're going to keep on going. So definitely here, negative 2x has been solved. So we're going to say let u equal to negative 2x. So du over dx, that is going to be negative 2. So that means du equal to negative 2 dx. All I need is dx. So what are you guys going to do right there? I'm going to divide it by negative 2. So here divided by negative 2. So then what you're going to get? Negative 1 over 2 du equal to cancel. Dx, we got it. So dx equal to negative 1 over 2 du. So we got it. What else do you need to do? The integral. So 0, 1, we need to convert it to in terms of the u. So u equal, when x is a 0, negative 2 times 0, it's a 0. So 0 go to 0, good. And then u, when x equal to 1, negative 2 times 1, it's going to be negative 2. So it's going to be 0, negative 2. But again, this does not make sense. You have to change that order. So watch me, we already did this type of question. So we have integral, it's converted 0 to negative 2, correct? E to the u and dx is negative 1 over 2 du. I don't like this order. It's not really make sense, 0 to negative 2. So we need to convert it. What do you remember? We are going to change the order with the negative. And then now negative 2, 0, e to the u, negative 1 over 2 du. Beautiful. Does it make sense? Because this order does not make sense. 0 is a large number than negative 2. So we have to change that order from negative to 0 with the negative sign. Got you. We good. So now I'm going to bring all the information. So this negative 2, I'm going to bring to the front. So double negative change to positive 1 over 2, negative 2 to 0, e to the u du. So when you take the integral e to the u with the integral, same thing. 1 over 2, e to the u from negative to 0. So that means capital 0 minus capital negative 2. So let me just minimize a little bit. So we're going to subtract that. So therefore 1 over 2 e to the 0 minus, 1 over 2 e to the negative 2, right? So that means this is going to be 1. So 1 over 2 times 1 minus 1 over 2. Make sure e to the negative 2, it's the same as 1 over e to the second positive reciprocal, the negative exponent. So therefore, final answer. Let me just minimize it. It's a 1 over 2 minus 1 over 2 e to the second. That's your final answer. If you want, you can change to the decimal by using the decimal, but that's fine. Woohoo! We got this. How you feel? Getting better? So you don't need to afraid of anything. We learn how to use substitution. All the outcomes are given. Just make sure if you have a specific integral, convert it in terms of the u variable. Just take a little techniques so you can get the answer. So I'm gonna keep practicing with you because you need to practice. I'm gonna do the next one and you're gonna think about it, or you can pause the video and do yourself first and come back. Anyway, we're gonna do all the step-by-step work. All right, here we go. Second question. Okay, here, I'm gonna change this color. So this one, everybody see you. What happened? X to the second has been subbed. You see that? Into e to the x. And then we need to find out what the 4x times dx, isn't it? So we see the structure, we checked. So let u equal to x to the second. And then du over dx is 2x. That means du is 2x times dx. I need to find out 4x times dx. You're going to multiply 2 on both of sides. So then what happened? 2 du will be 4x dx. That's what I need. 4x dx is equal to 2 du. Beautiful. What else? What else do we need to consider? The interval, 1 to 2. Yeah. So what happened? We have a 1 to 2. This is in terms of x. I want to convert it to the interval in terms of the u. So u 1 to the second become 1. So 1 become 1. U 2 to the second become 4. Oh, this is 4. This is a beautiful order 1 to 4. So now we have all the information. So finally, we have e to the u, right? And 4x dx that has been 2 du. And then from 1 to 4, this is a great order. Okay, bring the number 2 to the front. E to the u du. We know this one is going to be e to the u from 1 to 4. And we do have a 2 into the front. So that means capital 4 minus capital 1. So 2 e to the 4 minus 2 e to the 1. So that is going to be, you can now 2 e to the 4, e to the 1 is the same. So you can change it to the decimal if you need, but this is fine too. All right, we got this, getting better and better. Aha, how you feel? How you feel? Better? Yeah? So we're gonna do it. We're gonna do it. The following question. So the next question, we already practiced it without the interval, but let me show you that example. Are you guys okay? So slowly, surely, let's continue right there. Oh. So we know what is going on here, right? We know what is going on here. Let me get rid of it. So here, we need to modify to find out the subfunction. So modify, it means 1 to 2, and this is definitely definite integral. We have a 3 plus a 3x. You remember this question? 1 over x to the second plus 2x dx. Why? Because I want to find out the sub, because this guy is going to be 1 to 2, 3 plus a 3x, x to second plus a 2x to the negative 1 dx. Right? So they're going to be reciprocal so that I can find out x to second plus 2x has been subbed. But in this time, we have a specific interval 1 to 2. Later, we're going to convert it. So let's do this work. We did this one, but let me try it again. Let, what happened? U equal to x to second plus 2x du over dx, 2x plus 2. So du equal to 2x plus 2 dx. I actually need what? 3 plus 3x times the dx, but we have a 2. So we have to modify. I'm gonna divide it by 2 everywhere first. Let's divide it by 2. So it is going to be 1 over 2 du equal to 2 cancel, x plus 1 dx. Are you okay? Because I divided by 2. Now you're gonna what? You're gonna now multiply 3 every both sides. So what happened? 3 over 2 du. So 3 gonna be distributive property. That's actually what I need. So we have 3x plus 3 dx, exactly 3 over 2 du. Okay, we good. We're done with the substitution. And now let's talk about the interval. We have a 1 and 2. This is in terms of the x variable. I want to convert it to the u variable interval. So u, when x equal to 1, 1 to the second, 2 times 1. It become 3. So 1 become 3. And then when x equal to 2, right? 2 to the second, 2 times 2. 4, 4, 8. Oh, this is a nice order, 3 to 8. So we don't need to change anything. So what happened? Finally, we have everything. So now 3 to 8. So this one become u to the negative 1. And then 3 plus 3x dx, that's a 3 over 2 du. Are you okay with that? I'm going to bring 3 over 2 to the front, 3, 8. And then you remember 1 over 1 to the negative 1 is 1 over u du. This guy is going to be what? Number 4, ln u. And then I do have a 3 over 2 in the front. And then here we have still 3 to 8. This is definite integral. So let me minimize it. So this means capital 8 minus 3. So we have 3 over 2 ln 8, because it's a positive number anyway, and 3 over 2 ln 3. So all you need, you're going to go to decimal. So this is now positive 8, positive 3. So let me go to decimal and type it. So we have 3 over 2 ln, what was it? 8 minus 3 over 2 ln, oopsie, not there, ln, ln, and we have subtract 3. So the answer is 1.47 approximately. Can round up. Does it make sense? You got this. Beautiful. Okay. So make sure you can do this without looking at my solution. I'm helping you to practice. So you have a lot, you have enough time to when you're solving the quiz. We have 3 attempts. So try to solve each question on your own. You know, exactly, they're going to ask you, can you write down the steps, right? All right, so one last question here. So we already know tangent x, we proved that. Go up, 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 up. We proved that, where are you? Tangent x. If you take the integral tangent x, we just proved that it is ln secant x. So we're going to just think about same strategy. So we already know here. Integral tangent x is absolute value secant x. But we have here, we have the interval from 0 to pi over 4, isn't it? So all you need to do, you're going to subtract. So we have here 0 pi over 4 tangent and dx means absolute value secant x from 0 pi over 4. That means capital pi over 4 minus capital 0. Isn't it? Isn't it? Isn't it? So that means secant pi over 4 minus secant 0. So all you need to do, you're going to go to decimal. So it's not going to be, you don't need to write absolute value anyway, because it's going to be positive number. So secant pi over 4 minus secant 0. So let's type that information. So here I have a ln. Oh, actually, I forgot the ln. Sorry about that. So if you go up, 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 there's ln. I forgot the ln. So here, ln. So we have ln, 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 right? So ln, you're going to subtract. So go to decimal, ln. We have a secant. What is it? Pi over 4. So pi over 4. So it's saying undefined. So I have a little bit of maybe I have to change. Oh yeah, this is not the form we are looking for. Secant, parenthesis, pi over 4. Yeah, that's a better form. Minus, we do subtract ln when secant 0. So secant 0. So you can find out the answer as a decimal because we cannot mentally calculate. Always you need a calculator. So 0.3465. 0.3465, that's your answer from 0 to pi over 4. So you guys know, we already proved that taking integral of tangent x is an absolute value, ln secant x. We already proved that. So all you need to do, plug in the pi over 4 from 0 to pi over 4. So therefore, you can find out the answer simply. So this is pretty, we already proved it. All right, so sounds good, okie dokie. And you guys been working so hard, I know it. Now, I strongly recommend you get your notebook. You guys have your own notebook. And then my lecture note also, I'm providing the empty file. So you can download it. You can work with that with your iPad, or you can print it out. You can study with that. There are so many way you can study with my lecture note and video. But I want you guys to have your own notebook. You know what I'm saying? So because for quizzes, you can solve all the quizzes on your notebook. So that's going to be your Bible for the final exam or test or whatever. So keep building your knowledge with your own resources. All right, so finally, the last question. Here we go. So, we talked about taking integral, taking derivative. It's so amazing skills. It helps us to find out the area, especially the integral. It helps us to find out the area. It helps us to find out the volume later we're going to talk about. It helps us to find out, the relationship between velocity, position, and acceleration. We know there are a lot of applicational problem. So here is one thing. Let me read it. A population of fruit flies increases. Okay, they're increasing at a rate with the following function. So this is like a velocity function. There's initial number 100. How many were there in 10 days? So think about it. This is 1 point, I believe, 1.4, the net change. If you take the derivative over the time position function, you got the velocity function, correct? Let me write it. P function, position, you got the velocity function. If you take the derivative of the velocity function, we got the acceleration function. In other words, if you take the integral of the velocity function, you're going to go back to the position function. If you take the integral of the acceleration function, you're going to go back to the velocity function. We talked about it. So we have a velocity function as a given, 2 times e to the 0.02 t. If you take the integral, right, you will get back the original position function. So the position means in this context, the number of flies is changing over the time. Correct? So if you take the integral, you will get back the original, the number of the flies are actually changing. But here, especially they say in 10 days from 0 to 10. Plus, there was an initial 100. So that's something you need to set it up. So we know this is a very, very good question. You can convert it. So this is, you can convert it. This part, let me just go highlight it, e to the 002 t, but I'm gonna just bring 2 to the front, 010, e to the 0.002, 02t dt. Do you remember? If you have a constant with the exponential function, go up, right there. here, constant, you keep it and divide it by that constant. So therefore, if you take the integral with that format, this is keep the e to the 0.02t divided by 0.02. That's how you take the integral from 0 to 10. And I have 2 into the front. Okay, one more time. If you remember the note, take the integral e to the nt dt. You're gonna keep the e to the nt divided by that constant. So that was number 2 property. So we just utilize same, we just apply that here. So it means same, and then we have a plus 100 at the end. So let me just finish up this, capital 10 minus capital 0, right? So let me finish that part. So that means 2 times e to the, actually, I can simplify 2 divided by 0.02 first. What is a 2 divided by 0.02? 2 divided by 0.02? It's 100. So 2 divided, so it means we can simplify. So 2 divided by 0.02, 100. So that e to the 0.02t from 010 plus 100. So therefore, 100 e to the 0.02 times 100 minus 100 e to the 0.02 times 0. So this is capital 10. This is capital 0 plus 100. So if you calculated 100 e to the 0.02 times, oh, actually not 100, it's a 10, my bad, 0.2, and then 100 e to the 0 plus 100. So 100 e to the 0.2, this is a 1. Adding 100, they're cancelled, minus plus. The answer is 100 e to the 0.2. You can change it to the decimal if you want. It's going to be approximately 122.14. Use a decimal. So that's something you can utilize the same concept in one of the application problems. All right, are you guys okay with that? So I hope this video helps you to understand, how to take the integral with the log or exponential function. And then all the concepts are accumulated. Chain rule, use substitution is everywhere. So you need to now have a better understanding how to, how to see the structure of the function. You never know what kind of function you're going to deal with. If you have a composition function, substitution, exponential, log, there's a specific, techniques you're going to utilize it. So you can finish all the 1.6 quizzes and you can make a time to review. Okay, so I will stop recording at this moment. Thank you for watching, everybody. I will see you guys in the next video. See you soon. Thank you. Bye-bye.